Hello Calc BC. I decided to go ahead and make a small video of some of these problems just so you can see how I would work these. So if I was asked to find ds dt, I know that that is taking the derivative of s with respect to t. And I notice that I have in the form of an f of x times a g of x, right? And so what I'm going to do is use the product rule because I see that this is a product of two functions. So my product rule is take the first function and multiply it by the derivative of the second, plus take the second function and multiply it by the derivative of the first, and then simplify. So I've got t to the 7th times secant squared t plus 7t to the 6th times tangent t. Remember to always put your polynomial in front of your trig function, okay? So you want that in the front. All right, so number 2, dy dx. And you can look at this as 11 sine x and use the quotient rule, or since you know that 1 over sine x is equivalent to cosecant x, you could solve this as 11 cosecant x. So I'm going to show it to you both ways. So let's use the quotient rule first, low d high. Well, the derivative of a constant is 0 minus high d low over the square of what's below. And of course, this goes to 0, negative 11 cosine x divided by sine squared. And typically what we do here is we make this like this. So negative 11, this right here is cotangent x, and this is cosecant x, right? So typically that's what we're looking for. And if you solved it, if you knew that it was equivalent to 11 cosecant x, and you were trying to find dy dx, you'd say, okay, that's going to be 11 times the derivative of cosecant. The derivative of cosecant is negative cosecant x, cotangent x. So there it is right away using the derivative of cosecant. Okay? All right, here's the next one, dy dx. So I notice that this is, remember, terms are separated by positive and negative signs. So this has 3 terms, okay? It's 3 terms. And then when I look at each term, I notice I have a function times a function here. I have a function times a function here. And this is just a whole number times a function, okay? So I had to do these 3 terms separately. So to find dy dx, I'm going to, on the first term, I'm going to take first times the derivative of the second plus second times the derivative of the first. Okay, that's my first term. And now my second term, I'm just going to say plus, because I know I'm going to do product rule, but I want my first function here to be negative 7x, okay? So I've got my first times the derivative of the second plus second times the derivative of my first. So the derivative of my first was negative 7x, so the derivative would be negative 7. Now, I've only got one left, this negative 7 cosine, so negative 7 times the derivative of cosine, which is negative sine. Okay, so now I just need to simplify. So negative x to the 5th sine x plus 5x to the 4th cosine x minus 7x cosine x minus 7 sine x plus 7 sine x. So these actually cancel. and then negative x to the 5th times sine x plus 5x to the 4th times cosine x minus 7x cosine x would be my final. Okay. Number 4. This one's easy. It has 3 terms, so I'm just going to take the derivative of each. So I've got 7x to the 6th minus, and then the derivative of cosecant is negative cosecant x, cotangent x, and then the derivative of 5 is 0. So this becomes 7x to the 6th plus cosecant x, cotangent x. Oops. And then find the indicated derivative. This time they want us to find y double prime. So to find y double prime, I first have to find y prime. So this is going to be 6 cosine x, right? This is a constant times the derivative of sine. And then when I take the second derivative, it's just going to be 6 times the derivative of cosine. So my second derivative is going to be negative 6 sine x. And then number 6, find the indicated derivative. Again, they want a second derivative. This time, they've given us a function times a function. So we have to use the product rule on this one, okay? So our first derivative is going to be first times the derivative of the second plus second times the derivative of the first. Okay, so our first derivative is 2x cosine x plus 2 sine x. Now to take our second derivative, we've got a product here that we have to use product rule on, but this one right here, we're able to just use the constant being multiplied. So we've got first times the derivative of the second plus second times the derivative of the first, and then plus 2 times the derivative of sine, which is cosine. So our second derivative, negative 2x sine x plus 2 cosine x plus 2 cosine x, and you can see that those are your like terms. So negative 2x sine x plus 4 cosine x is going to be your second derivative. That was number 6, and and they've got 4 cosine x. Yep, they've got that one. Okay, so number 7. I wish I could. I wonder if I can do that. I wonder if I can, like, take this whole thing. No, it doesn't like it. And move it. Can I move that? I would like to be able to move that. I don't think it's going to let me. All right, that's, oh, goodness. Come on. Work with me. Okay, so we're going to have to just work number 7. I have to get up and turn my light on so I can see. Sorry about that. Number 7, let's just erase all this. Hopefully you can go backwards and look at it again if you need to. Okay. Change colors. The equation S equals negative 6 plus 3 cosine t gives the position in s in meters, of a body moving on a coordinate line in t seconds. Find the body's speed. Yep. T equals pi over 3. So if you have position, the velocity is the derivative. The derivative of -6 is 0, and then plus 3 times the derivative of cosine, which is negative sine. So your velocity is -3 sine t. Your velocity at pi over 3 is -3 sine pi over 3. And I think over here, okay, pi over 3, 180 divided by 3 is 60. So this is square root of 3, this is 1, this is 2. My sine is square root of 3 over 2. So my velocity is -3 root 3 over 2. But my speed is the absolute value of velocity. So the absolute value of -3 root 3 over 2 is positive 3 root 3 over 2. And so that would be B. Number 8, the equation S equals 4 sine t minus cosine t gives the position. Find the body's velocity when t equals pi over 4. So if we've got position 4 sine t minus cosine t, our velocity is going to be 4 cosine t, because the derivative of sine is cosine, minus the derivative of cosine, negative sine t. So my velocity is 4 cosine t plus sine t. And so my velocity at pi over 4 is going to be 4 cosine pi over 4 plus sine pi over 4. Well, the cosine of pi over 4 is 1 over the square root of 2. The sine of pi over 4 is 1 over the square root of 2. So 4 over the square root of 2 plus 1 over the square root of 2 is going to be 5 over the square root of 2. And if you rationalize it, you get 5 root 2 over 2. And that's positive. That one's going to be B also. Okay, number 9. Find the equation for the lines that are tangent and normal to y equals cotangent at x equals pi over 4. So your function, is y equals cotangent x. So your y prime is derivative of cotangent is negative cosecant squared x. And so I want my y prime at pi over 4 to get the slope at pi over 4. And so this would be negative cosecant. Now be careful how I do this. Cosecant of pi over 4 squared with the negative on the outside. So cosecant is the reciprocal of sine at pi over 4. It was 1 over the square root of 2. So this would be just square root of 2 over 1. So this is, those cancel, this is going to be negative 2. And so that is our y prime at pi over 4. That's the slope of our tangent line. Now we have to figure out what our point is. And so to do that, we would say, okay, pi over 4, comma, and it'd be cotangent of pi over 4, because we're going back to this function. So the cotangent of pi over 4, if you've got your 45, 45, 90 right here, and your cotangent, your tangent is 1 over 1, your cotangent is also 1 over 1. So this is going to be pi over 4 comma 1. So our equation of our tangent line is going to be y equals, I've got my slope of negative 2, or my derivative, and then x minus pi over 4, and then plus 1. And they put it in slope-intercept, it looks like. So let's go ahead and distribute that negative 2, negative 2x, and then we've got a positive pi over 2 plus 1. So there's my tangent. My normal is going to have a slope, I'll just put slope of the normal, is going to be the negative reciprocal. So it's going to be positive 1/2. So y equals positive 1/2 times x minus pi over 4 plus 1. Y equals 1/2 x minus pi over 8 plus 1 when I distribute it. So looking for this equation and this equation right now. So we've got negative 2x plus pi over 2 plus 1, positive 1/2 minus pi over 8 plus 1. It looks like this one right here. And number 10, find all points on the curve y equals the sine of x between 0 and 2 pi where the tangent line is parallel to the line y equals 1/2 x. Well, if it's parallel to y equals 1/2 x, then it's also going to have a slope that is 1/2 because parallel lines have the same slope. So I know that the slope of my tangent is going to be 1/2. So I've got y equals sine of x and is my function, and between 0 and 2 pi, tangent line being parallel to that. So I want to know where the derivative, which would be cosine x, where does that equal 1/2? So I'm looking for the quadrant where the cosine is positive. Okay, so all students take calculus. That's my telling me where they're all positive. This is only sine positive. This is only tangent positive. And this is only cosine positive. So we're talking about this quadrant and this quadrant. So the first and the fourth, where the cosine is 1/2, meaning that this would be 1/2 like that. And this would be square root of 3. This would be negative square root of 3. So this angle is a 60-degree angle, which we also know as pi over 3. And since it is between 0 and 2 pi, my other angle is going to be found by going all the way around and being 1 pi over 3 shy of 6 pi over 3, right? Because 6 pi over 3 is 2 pi. So when you go all the way around, you've gone 2 pi. And if we're doing it in terms of 3, then 1 away from 6 pi over 3, this would be 5 pi over 3. So it's happening in two spots, the two x values that will give you the cosine of x, which is the derivative of sine, is equal to 1/2. And so for this one, we just now, oh boy, where did I go? It's way up here. It's number 10. We just now have to find the corresponding y value, right? Because they're asking us at those points. So I've got pi over 3 and 5 pi over 3, and I put them back into my original function. So the sine of pi over 3 is going to be square root of 3 over 2, and the sine of 5 pi over 3, I can just use this triangle right here, negative square root of 3 over 2. So those should be the two that I'd be looking for number 10, pi over 3, comma, square root of 3 over 2, and 5 pi over 3, comma, negative square root of 3 over 2. Looks like C. There it is. Okay, number 11, find all points on the curve y equals cosine x where the tangent line is parallel to negative x. So you're going to do the same thing on that one. You know, you've got your y equals cosine x, you've got your y prime is negative sine. You know that if it's parallel to this, then the slope of the tangent is going to be negative 1. So you want to know when is the derivative, which is the slope of the tangent, equal to, negative sine x, negative 1. And so if I divide by a negative on both sides, I want to know where the sine of x is positive 1. And so sine of x is going to be positive 1 only in one spot, and that is pi over 2. So we're going to say that that is true at pi over 2, and then we go back, because this point is on your original function here, we're going to go back here to find the y value. Cosine at pi over 2 is 0. So this is going to be A. There was one down here. Oh, this one. This number 17 was one that somebody, I think, wanted me to work today. A weight hanging from a spring bobs up and down with a position function S equals F of t, S in meters and t in seconds. What are its velocity and acceleration at time t? Describe its motion. So velocity is going to be 5 cosine t. Okay, that one's easy. Acceleration is going to be the derivative of that, so that's going to be negative 5 sine t. Oops. So that would be your answers there. 5 cosine t, negative 5 sine t. Describe its motion. So it starts at what? At t equals 0, it's going to start at 0, okay? And then oscillates between what and what? Well, it's going to oscillate between, because look, this is its position. It's going to oscillate between 5 and negative 5. Or negative 5 and 5, however you want to say it. The speed is greatest when, well, think about what when the speed is the greatest, okay? Think about that. When would the absolute value of velocity here be the greatest, okay? And then the acceleration is the greatest when. So, what would you think, when would you think the speed would be the greatest? When would you think the velocity would be the greatest?